Okay, so this is question 2 on the 2021 mock paper. So part A is asking us to simplify this quite complicated equation fully. Okay, so the first thing we're going to want to do is factorize each part of the fractions fully. So first we're going to label everything. 1, 2, 3, and 4. For 1, you can see that it is 25x squared minus 16, which is a difference of 2 squares, meaning that simply simplifies down into 5x minus 4 and 5x plus 4. Now for equation 2. It is just a simple quadratic. So we'll simply multiply the 3 and 7 together to give us 21. And the factors that will give us 20 are 1 times 21. So then you put that back into the equation. And then factorize fully. And then it's completely factorized. And then that'll give us 3x minus 1 multiplied by x plus 7. And now equation 3, that's as simple as we're going to get. And then equation 4, it looks a bit like a quadratic, but slightly more complicated. So the first thing we're going to want to do is just sub out 3x squared from each term. And then we can see that the quadratic inside the bracket is the same as the quadratic in question 2. So we can simply sub in the factorized version. Okay, so now that we have everything simplified, we're going to want to work on simplifying the equation. So because we are dividing two fractions, that means we can multiply by the inverse of the second fraction. So once you sub everything back in, we can see that we have a lot of cancelling to do. So the first thing is that 3x minus 1 cancels, the x plus 7 cancels, and the 5x plus 4 cancels. So then we're simply left with 3x squared multiplied by 5x minus 4, which is the simplest answer. Okay, so now moving on to part B. Part 1 is saying that given that x minus 2 and 2x minus 1 are factors of ax squared plus bx plus 6, find the value of a and the value of b. So first we're going to work with what we know. So we know that x minus 2 and 2x minus 1 are factors. So we can use these factors to find the roots by letting them equal to 0. So then we get that x is equal to 2. And x is also equal to a half. So now what we're going to do is find two simultaneous equations by subbing each value of x into the equation and letting it equal to 0. So the first equation is pretty simple. Once you multiply it all out, it should look like that. The second equation is a bit more tricky because there are fractions involved. So simply multiplying everything together will give you something like this. Now, to simplify it further, we're going to want to find a common denominator for all of the terms. So that'll be 8. So what we're going to do is transform each fraction so that its denominator is 8. So now that everything is on the same denominator, we can just add everything together. And since it's all equal to 0, you can simply leave out the denominator and you get the equation of a plus 4b plus 50 is equal to 0. Now we will label both of these equations, equation 1 and equation 2. So we're going to want to choose one of the variables to cancel out. I'm going to choose the b. So just to make sure those are separate, we're going to need to let the b's be equal but opposite. So that means multiplying the first equation by 2. And now because we want to cancel the b's, we are going to multiply the second equation by -1, just to make sure the signs are flipped. And then adding that together, you get 15a, those cancel out, minus 30 is equal to 0. And moving the minus 30 over to the other side, we get 15a is equal to 30. Dividing both sides by 15, we get a is equal to 2. And now to get a value of b, we simply have to choose one of the equations to sub our value of a back into. I'm going to choose equation 1. And then it should look something like this, and we simply multiply everything out. Bring the 26 over to the other side. Divide everything by 2. And you'll get b is equal to minus 13. And there we have solved for the value of a and the value of b. Now, the next part says, hence or otherwise, find the third factor. So we know that two of the factors are x minus 2 and 2x minus 1, as that was given to us in the question above. And we're going to let the third factor equal to y. So if all the factors were multiplied together, it would give us the original equation. So we're going to multiply the two factors that we know together. And sub in the values for a and b that we know from the last question. And then gather the like terms on the left side of the equation. And now what we're going to want to do is solve for y. Now to do that, we want to divide this by this. And to do that, we're going to use long division. So the setup for the long division should look like this, and it's quite easy to solve. So to get from 2x squared to 2x cubed, we'd have to multiply by x. And now what we're going to do is multiply everything on the left-hand side by x and take it away from the equation we're dividing. So once you've multiplied everything by x and are taking it away, the first term should cancel, and then it'll give us a new equation to work with. So once you've multiplied everything by x, you simply take everything away. So 2x cubed minus 2x cubed will cancel. X squared plus 5x squared is 6x squared, and minus 13x minus 2x is minus 15x. And then we're going to want to bring down the plus 6 from up here. And now we can see that to get from 2x squared to 6x squared, you'd have to multiply by plus 3. And now what we're going to do is multiply everything on this side by plus 3 and take it away. And if you've done your long division correct, everything here should equal 0. This cancels, and this cancels. So that gives us 0. Therefore, we can say that the third factor is x plus 3. And that's question 2, all done.